Hello? Hello? Hello?
Hello, sir.
Can you hear me now?
Yes.
Okay, that's good. Miss
Dolly.
Miss Dolly, right? Okay.
We can hear you now.
You can hear me now?
Yes.
Good.
Finally.
Finally, yeah. No, technology can act funny sometimes.
Yeah.
So let us start then. I will share my screen so we can begin from where we stopped last week. So last week we stopped at addition rule. Let me refresh your memory by showing what addition rule is again, by explaining it. So the addition rule, the keyword is OR. The keyword, make it a little bit big. Keyword is OR. When you see the OR, you know you're gonna use addition rule. Let's say that we have two events, event A or event B. So that the probability of event A or B becomes probability of A plus probability of B minus probability of A and B. A and B.
So this is the formula?
Yeah, this is the formula for addition rule.
Okay, great.
Probability of A plus probability of B minus probability of A and B. This is general formula. So even if the event is, even if the event is mutually exclusive, I explained what mutually exclusive event is. You can still use this because if the event is mutually exclusive, this part will turn to 0. So you have only these two.
I don't understand what mutually exclusive is. Could you explain that for me, please?
Mutually exclusive, like I explained last week, two events are mutually exclusive if they cannot occur at the same time.
Right, right. I got you.
But then if that is the case, this part will turn to 0. A good example is you cannot be a Democrat and a Republican at the same time. You either be a Democrat or a Republican. That is a good example of a mutually exclusive event. So that's what we did last week. But let me refresh your memory by solving two examples. Look at this example here. It says the frequency distribution here, this one here, shows the volume of cells in dollars and number of months which a sales representative reached its sales level during the past 3 years. See, 0 to 24,999 in 3 months, 25,000 to 49,999 in 5 months, and so on and so forth. Now, if this sales pattern continues, what is the probability that the sales representative will sell between 75,000 and 124,999? See? Now, actually, the way they frame this question, you might not even know that it is. But you see, 75,000, that means this here or this one here. Because this is where you reach, excuse me, you begin from 75,000 and then get to the 124. So what is the probability that it will reach? You reach 75,000 to 99,999 or 100,000 to 124,999 next month. So let's see that A is the monthly sale between 75,000 and 999. Then B becomes the monthly sale between 100,000 and 999. 100,000 to 124,000. So the probability that he will reach this sales level or this sales level within the next month will be probability of A or B, which is probability of A plus probability of B. Now, because this is mutually exclusive, if you look at here, either he's here or he is here. He cannot be both of them. That's why you don't have probability minus probability of A and B.
Question. So 36 is the total of the months?
If you add all of them, you're gonna give 36. We add all this in the calculator. If I add all this frequency, that'll give you 36.
Okay.
So now probability of A or B becomes probability of A, which is this level, and it is 7 out of 36. Probability of B will be 9. B will be 100 to 124,000, which is 9 out of 36. Again, how do we get 36? By adding all these months. If you add all this in your calculator, you get 36. So the probability of A or B becomes the probability of A plus the probability of B, which is 7 out of 36 plus 9 out of 36. So this we can do on a calculator as in our calculator. Where is my calculator? It's gonna be somewhere. Okay, that means I have to open a new page. What is the? I think it should be here. Interesting. Okay, let's see. Let me open a new web page where I can get the calculator. This most. So it's now opened, and I can share it here. So let me share it. Okay, new share. There's most. And what we are looking for is 7 over 36 divided by 9 over 36. So that we have 7 over 36. Okay. Plus 9 over 36. That was 0.4444. So that means 44.4%. So that's why you get the answer here as 0.444. So that the probability that he reached this sales volume or this sales volume within the next month is 44%, 44.4%. If you have a question, you can ask me.
Does it tell you like how many decimal points you have to round it to?
This one didn't tell us, but the homework question will tell you. If you say 1 decimal place, you gotta be 0.4.
Right.
If you say 2 decimal, you gotta be 0.44.
Okay.
So another example would be, look at this example here. It says, a blood bank catalogs the types of blood, including the positive or negative RH factor given by donors during the last 5 days. A donor is selected at random. Find the probability that the donor has type O or type A blood. You can see all the types here. Type O, type A, type B, type AB, RH positive, RH negative. So when you put all these things together and get the totals, for example, if you add these two, 156 plus 28, 156 plus 28, 156 plus 28, give us 184. And that is what we have here. 184. So in the similar way, if you add this and this, you get 164, and so on and so forth. Then at the end of the day, if you add all of this, 184 plus 164 plus 45 plus 16, you get 409. You can double check this in your calculator. Also, if you add 344 plus 65, you get 409. That's why we call this part the grand total. So when you have this kind of chart, first thing is to get the totals, and then you can now find the probability. It says, find the probability that the donor has type O or type A blood. This is the keyword that tells you that it's going to be addition rule. Type O or type A. So type O, let's type O. I think I'm going to move this on the left side. Let's type the event type O or type A are what you're looking for. So the probability of type O or type A will be, this is type O, this is type A. You can see that they have no connection. Because of that, either you are type O or you are type A. So we say that they are mutually exclusive. They cannot occur at the same time. So we have that the probability of type O or type A will becomes the probability of type O plus the probability of type A. For type O, we have total is 184. So 184 over 409. I'm going to write it down. 184 over 409. Then the probability of type A. Type A is 164 out of 409. 164 out of 409. And that will give us the answer. You can get it from the Desmos calculator that we have. So this gives us equals 184 divided by 409. Okay. Then plus 164. I'm sure that you notice that I always put them in parentheses. It is just to make sure that it follows the order of operations. Okay. Sometimes if you don't put them in parentheses, the calculator will do only one part and not the other ones. Therefore, you may not follow the order of operation. So that's why if you're putting them in the calculator directly, put them in parentheses so that you'll be sure that the calculator follow the order of operation. So our answer is 0.85050855, continued. But usually I stop at 3 decimal places. So you're going to be 0.851. And you can see it from here, 0.851 approximately. So there's 85.1% chance that it will be type O or type O or type A blood. Questions? Any question? Okay, very good. Now, suppose we ask this question. Find the probability that the donor has type B blood or is RH negative. We draw the line. Look at type B blood. Look at RH negative. You can see that they intersect here. This person at this intersection have type B and is also RH negative. So this one is not mutually exclusive. The other one we did, they did not intersect. This one is type A, this one is type O. So O or A. This one, they cannot occur at the same time. That's why we say that they are mutually exclusive. But this one, they cannot. So they can, because you can get somebody who is type B and at the same time is RH negative. So in that case, the formula will now becomes type B or RH negative become type B plus RH negative minus type B and RH negative. This is simply a reflection of the formula I wrote here for you. Probability of A or B equals probability of A plus probability of B minus the probability of A and B. This is just a typical example of that. Type A or RH negative, subtype B or RH negative. So for type B, we have the total as 45 out of 409. You can see right here, 45 out of 409 plus RH negative. You can see it follow it from here. You see the total is 65 out of 409. So 65 out of 409 minus type B and RH negative. So type B and RH negative is right here. Type B, RH, this is the intersection right here. But this represent type B and RH negative, which is 8 out of 409. So let me write it down and then we can put it on the calculator. 45 for 409 plus 65 for 409 minus 8 for 409. So let's put it there and we'll get the answer I have here. We have 45 over 409. Okay. Plus 65 for 409. Then minus 8 over 409. Okay. 0.249388. So we stop at the third decimal place here. 0.249, which is what you have in the notebook. Questions?
Yes, sir.
Yeah, go ahead.
Yeah, I was wondering why the first question did not follow the rule of addition and this one followed.
Because the first one is mutually exclusive. See?
So what rule did that one follow?
The same rule. Remember, I told you that if it is mutually exclusive, this side will turn to 0.
Oh.
So you have only these two sides. See? So because this is mutually exclusive, if you want to write this, if you want to write out all of them in that question.
Right. Can you highlight that part and write if it might be
right here. Type O and type A will be on this side, and you're gonna be 0. You're gonna be 0 over 409, which is 0. That's why they didn't write it.
I got you.
See? Because you can see this is separate. This is separate. It's the same rule. So that on this side, if it is mutually exclusive, that means they cannot occur at the same time. The top side, which is probability of type O and type A, will be 0. So there's no point writing it down because it's going to be 0. But here, they are not mutually exclusive. You can see type A here, so type B here, and I can see RH negative here. So they intersect here. So because somebody can be type B and RH negative, we add that part. And see, because you're going to be 8 out of 409. So if this is mutually exclusive, then this part will not be necessary. We will be left with only these two sides. Okay?
Sir. Yes, sir. Thank you.
So that is basically how. So they can apply this in so many examples when you practice with your textbook. Let us go to something new, which is permutations. We are rounding up this chapter today. Permutation simply means an arrangement of n objects or arrangement of objects in a specific order. They're going to be a specific order, excuse me. To understand permutation, we need to understand one important concept. We call it factorial notation. If you can see this here, you can see that we have n and we have the exclamation mark. It is called the factorial. this mark here is called a factorial, say n factorial. Let me show you how it works. If I say something like 8 factorial, see, it means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If you have a question, ask me. I don't do chatting in the when class is going on. So if you have any question, ask me in the classroom. So when you evaluate this using the calculator, you see that you have 8 times, I got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 40,320. 40,320. 40,320. So in a similar vein, if I say something like 5 factorial, it means 5 times 4, excuse me, 4 times 3 times 2 times 1. So 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So whenever you see this kind of thing, you know that's what you're going to do. Now, based on that, but we can get it directly from the calculator without doing all this multiplication. But then you wouldn't know what the calculator is saying, is doing, until you understand the principle. So you can, they have one example here. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, which is 720. Now, permutation, in permutation, we arrange the object in a specific order. And the formula for it is given, let's see, right here. NPR is n factorial divided by n minus r factorial. So it depends on the kind of calculator you are using. For example, my calculator here shows me where I can find factorial. If I click here, I can see it right here, NPR. I'm sorry, for permutation, see NPR. And this is factorial right here. So if I write 8 factorial, for example, 8, and I come here and put factorial, it will give me the answer right away. So it depends on the calculator. You have to check the manual of the calculator to see which parts work for permutation. Let's do an example. We have this question. So this is the formula right here, n factorial over n minus r factorial. So let's do it with the calculator. It says here, find the number of ways of forming 4-digit codes in which no digit is repeated. Now, in a digit, whatever the number of digits you are forming, every number consists of 0 to 9. Am I right? Am I right or wrong?
Yeah.
So every number you write, say numbers begin from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 digits. And so in this question, it is asking you find the number of ways of forming a 4-digit code, in which no digit is repeated. That means there is going to be a specific order. So that means out of 10 digits, you'll be forming 4-digit codes, which is, R is 4. So why are we using permutation for this type? Because it says no digit is repeated. So what you're gonna do is to use the formula here, n is 10 and r is 4. So that's see, n is 10, r is 4. Because it's a 4-digit code out of 10 digits that we have for numbers. So using this is the formula way of doing it in the formula. but we're going to use calculator to do it. So you have calculator, have 10. So you can click on NPR, which is N permutation R, 10, comma, and 4. That will give you the answer right away, 50, 40. And you can see it from here. There's 50, 40 ways. Other way you can do, you can say 10 factorial divided by 10 minus 4. 10 factorial means 10 times 9 times 7 times 8 times 7 times 6 all the way to 1. And 6 factorial means 6 times 5 times 4 times 3 times 2 times. So from here, excuse me, from here, this top here, 6 cancel out 6, 5 cancel out 5. 4
So all the ones that's the same as the one on the bottom cancel out, and then you will solve it that way.
Yeah, once you cancel out, you can just multiply the top. Yeah.
How do you know it cancels out?
Because
Because
6
it's
can
the
divide,
same
6 can
number
divide
at the
6.
top and the bottom.
6 can divide 6 evenly. Am I right?
Yeah. So it
Five
would be
times
times
five.
1.
That
I
would be 1.
understand, but what I don't understand is it has to be until 6. So like 10 out of 6, right? So you have to cross out the numbers until 6.
Yes, from here, cross out from here and from here. Or if you don't want to do that, you can do it from here. 10 factorial divided by 6 factorial, which would be something like this. 10. Let me put it here. 10 factorial, okay, divided by 6 factorial, 6 factorial, and that will give you the answer right away.
Oh, okay.
It's the same thing. Or you can just use the permutation
Hello, sir.
formula.
Hello. sir.
Yes, go ahead.
The NPR, where did you get it from? I'm looking
NPR,
on this calculation you did with the computer, with the calculator.
so, let's start with the N. You understand how I got N, right?
No, I mean with the how you solved it with the calculator is what I'm asking.
Yeah, I'm going to show you right away. Just I want to make sure that you follow from here. You understand how I got N,
Yeah,
right?
I know all of it. Yeah, I
Okay,
know
good.
all
So
of it.
what you're gonna do is, if you have your calculator, it depends on the calculator you're using. Mine is showing
She want to know what kind of calculator you're using.
the one I'm just using is right here at Desmos. So mine is showing hold on, let me see if I can get another calculator. This I should get one here. Can you see my screen, Miss Dolly?
Yes, yes,
So you can see the NPR right here. Can you see it?
yes.
On that?
Mine don't have it. That's what I'm saying.
Actually, it does if it is a scientific calculator. It depends
It
on one
is.
you're using. If you're using my own, this type, you can get it from, I don't know how to show you this, but you can get it from mine from, if you have PRB, you press it. Hold on, let me see.
Do
Okay.
you have to pay for decimal online?
No, this
you
one is
don't.
free.
It's free.
Yeah, it's free.
Oh, okay.
Just see, look at it. Can you see the website here? Once you type this, desmos.com/scientific, it will bring it up.
Oh, okay. That's right.
So every scientific calculator have this NPR. So long as it is scientific calculator, it has it. Otherwise, you can use Desmos. Okay? Is that it?
Yes, sir. Yes, sir.
Okay, good. So now, once you get this, now you can now say 10, 10, and 6. That's it. It will give you the permutation right away. Oh, is it 6?
Right, it's wrong. I was about to say.
My mistake. I put 6 instead of 4. 4. 50, 40. See it? Is arrow is 4. Remember, I wrote 6 by mistake. So you can see right. R 10 is N is 10, R is 4. That'll give you 50, 40. Miss Dollies, you good now?
Yes, sir. It's just that I don't have that NPR. That's why it's.
What kind of calculator are you using? What's the name?
Well, right now I'm using my iPhone to do the calculation, but it's
I don't Like,
Yeah, but
what you gotta do, turn your iPhone, turn
yeah,
it
to the
horizontal.
side. Yeah, I know, to the side. Then it has the second function and all that, the memory plus minus. In fact, it has
That's one is bigger than Miss Dolly. What you're using is bigger than me. See, we're the small people here, okay? So
no.
we are using the small one. Yeah, you are using the high tech, okay? So
Yeah,
so
I don't think Apple has that. So just use Desmo.
yeah,
Or
this will help
Maybe
you a
I'll
lot.
use, yeah, I'll get that. I'll use
And
that.
and you have seen that this can even do fractions too. So it's better to use it, and it's free. Who doesn't like free lunch? I haven't seen anybody who doesn't like free lunch yet. All right, look at this. For the 3 race cars started the 2007 Daytona 500. How many ways can the car finish first, second, and third? You can see there's a specific order: first, second, and third. That will automatically tells you that this is going to be a permutation. In that case, excuse me. So for the 3 cars, is your N. So N is for the 3, and R is to say how many ways. So R is 3 because you have first, that's number 1, second, that's number 2, and third, that's number 3. So R is 3. So you can put it in 43. If you go to your calculator, 43 MPR is already here. 43, comma, and then 3. That will give you an answer right away. 74,046. You can see it's right there. 74,046 ways. Questions?
No.
Okay, good. Ms. Ford, you there? I don't think it's.
on that problem right there, how did they get the 40? They did -3, right?
Yeah, 43 minus 3 is 40.
Okay, I got you.
Now, there's one we call distinguishable permutation. In this case, the number of distinguishable permutation of n objects, where it explains the, in this case, we have specific n1, n2, and n3 types. For example, in that case, you're going to use this broader formula: n factorial divided by n1 factorial times n2 factorial times n3, all the way to the number of distinguishable objects you have. Look at a good example. It says that a building contractor is planning to develop a subdivision that consists of 6 one-story houses. This is N1. 4 two-story houses. This is N2. This is your N2 right here. This one doesn't work. Then 2 split level houses, N3. See? In how many distinguishable ways can the houses be arranged where you have a specific order? So a building contractor is planning to develop a subdivision that consists of 6 one-story houses, 2 two-story houses. That is N2. And then, so out of this, so you can see that there are 12 of them. So your N, there are 12 houses subdivision. So N is 12. But N1, that's the big N is 12. So this splits, the partitions or the split that you have there will be N1 is 6, N2 is 4, N3 is 2. So it's gonna be 12 factorial divided by 6 factorial times 4 factorial times 2 factorial. Let's plug this in. And let me write it down, then we can plug it in. I got that. So we got 12 factorial over 6 factorial times 4 factorial times 2 factorial. So let's do it right away. You can see the answer here. It's 12 factorial. Okay. Factorial divided by, we got, I like to put it in parentheses, 6 factorial. Okay. Times 4 factorial times 2 factorial. And then you can close the parentheses here. 13,860 ways. 13,860 ways. Questions?
Questions, yeah. So wait, so hold on. I didn't see how you solved it. Was it a button in the calculator that you could put it into?
Say it again.
Did you put it in the calculator? Is it a way
Yeah,
that
I
you
did.
could put it in
I
the
put it right
calculator?
here. Yeah, see how I put it right there. See? That's why I got it.
Oh, okay. Hold on, but what you put it? Oh, you put it as a fraction.
Yes. 12 factorial
Okay.
divided by, so this bottom part of it, you have 6 factorial times 4 factorial times 2. So I put it in parentheses so that it will follow order of operation.
Okay, I got it.
Now, we round up with next thing, which is the combination. Now, for permutation, there have to be a specific order. See? An ordered arrangement. You gotta be in a specific order. But for combination, the one we're about to do now, there is no specific order. A selection of R objects from a group of N objects without regard to order. That's what make it different from permutation. So, and the formula is this: NCR, that means N combination R equals N factorial divided by N minus R factorial times R factorial. So all you have to do is to figure out what N is and what R is, and then you can put it in this formula, or you can put it in your calculator and get your answer. So let's see how it works. It says here, a state Department of Transportation plans to develop a new section of interstate highway and receives 16 bids. That means for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from 16 bidding? So N is 16. See? And R is 4 biddings. We're going to hire 4 of them. There's no specific way of hiring them. It can be first one, the 4th one, and the 3rd one. So there's no specific order. So your N is 16, R is 4. So when you plug it into this here, so 16 and R, you can go to your calculator. So I'm gonna clear this, go to combination. You can see what we have NCR here. Let's make sure you're seeing this. Okay. See NCR right here, click on that. 16, 4. And that will give you the answer right there. 1820 ways. And you can see the 1820 ways right here. Okay. So that's why I say there's no specific order. Questions?
Nope.
Now let's see how we can use this thing to find probabilities. We can use permutation or addition or combination to find probabilities of events. I'm gonna show you. I want to show you how to use it to find. Let's see. Look at this. It says a student advisory board consists of 17 members. 3 members serve as the board's chair. See, there's a chair, there's a secretary, and webmaster. See, each member is equally likely to serve any positions. What is the probability of selecting at random 3 members that hold each position? So there's a specific order here: a board chair, secretary, and webmaster, in that order. But your N is 17. So first of all, you get the sample space. Sample space is the permutation. So N is 17 and R is, see, board chair, secretary, and webmaster. So R is 3. See? So 17 permutation 3 will give you the sample space. So you have 17 Okay. 17, comma, then 3. Okay. 40, 80. I get 40, 80 right here as sample space. But you're looking for the probability of selecting, what is the selecting at random 3 members. At random, the 3 members that hold each position. So each of them have, well, there's only one possibility of way. 1 out of, you have 1 out of 40, 80. So probability of selecting 3 members, 1. They have only one chance. So we have, let's say we want to make one selection. Probability of selecting any of this will be 1 chance out of 40, 80, which is the sample space. So 1 divided by, so the first thing is to find the sample space, then find the probability, find the outcome, and divide it by the sample space. That will give you the probability we are looking for, which is 1 over 40, 80. So we have 1 divided by 40, 80. So when my students see this number here in this scientific form, they get confused. This thing means, actually it means 10 to the power -4. -4 means that you're gonna have 4 zeros before you have the actual numbers. So let's give us why you have it here as 1, 2, 3, 4 zeros before the first 2. Now I'm going to show you how you can use combination. I'm going to use something that is almost all of us knows about. How many of you buy lottery tickets? Anybody here bought lottery tickets, Mega Million, Powerball? Any of you guys done that before? Come on, I know you bought it before.
Yes.
Any of us did what?
I don't, but my aunt does.
You don't buy it?
No.
What is it?
Lottery ticket, Mega Million, or Powerball, or whichever one you buy. So I'm going to show you the probability of winning, the probability of that you can win or not. Most times you don't, because the way the game is structured, it favors the house more than you. But sometimes you can win. It's pure luck. Now let me show you. Let me use combination to show you how to calculate the probability of winning the Mega Million. So which brings us here, Mega Million. Of course, you know that it consists of 2 fields, 5 numbers that are drawn from the set of numbers from 1 to 70, and then the Powerball itself is one mega number for a set of 25 white ball. You can see right here. Let me if I can bend this. Yeah, I can bend it. Let me see if I can bend so you can see. Okay, let's see. All right, I'm gonna make it big. Okay, I'm just. Can you see it? Hello.
Yes, we can see it. We can see it better the other way.
Yeah, the other way.
No, it's all right. I think the number's facing. Is it numbers on there? What's that?
Yeah, just too tiny, right?
Yeah, just a little tiny.
Anyway, when you buy the ticket, when you get it, you can see that there are 70 numbers here, and you select 5 numbers from this one, and select 1 from here. So if the 5 numbers you selected from here and the 1 from the other side, if they all came out, you win the jackpot. Okay. So let's see probably that you can win the jackpot. How do you do that? First of all, you know that there are 17 numbers, white balls, which you're going to select 5 of them. So the sample space will be 70, arrow is 5, N is 70. So we're going to have 70 combination R, 70, I have 70, comma, out of arrow is 5 is 12,103,014, and that's what we got here. See? Now then you do the same for the mega ball. there are 25 numbers from which you select one of them will be mega ball. So you do the combination as well. 25 for N and S is 1. So you gotta be 25 and 1. So you got 25 here. And 1. You give us 25. Okay.
So is that the possibility of winning, or is that like, or does that include the people who actually participate in it? It don't include the
we're just
participants.
getting the sample space. We have not gotten the probability yet.
Okay.
We're going to get all the possibilities we are getting. Now we can now calculate. We got one for the 75 balls. We get one for the power ball. So we got for the power ball, we got this. So that see, which is 25. Now we can calculate the probability. The probability of winning the jackpot will be probability of getting all the 5 white balls correct, and then the power ball correct. So for the 5 white balls is 1 out of 12,103,314. And for the white ball, we get it as 25. So you're gonna be 1 out of 25. So that the probability of winning the jackpot will be this one here times this. So which will be let me write this down. 1 over 12,103,014 times 1 over 25. So we have it so we got the sample space using the combination rule. Then let's find the probability now. 1, okay, out of 12,103,014. Okay, times 1 over 25. Give it, see? So this times 10 to the power negative 9 means that you're gonna get 9 zeros before you can get the actual number. When you write it in the standard form, so this is what you're gonna get. You're gonna get 0.00. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Not even up to 1/50%. So you can see why when people can buy thousands of tickets, yet nobody wins it, because it's very it's difficult to win. So if you win it at all, you just you have a very good luck. Maybe the fortune smile on your side for some reason, and you win it, the jackpot. Question before we leave for today? Any questions?
You think you can open that test back up?
Not really, except
It just
sorry.
timed out on the middle of the test.
Timed out.
It timed out.
Remember, I gave you 2 chances though.
No, the time had ran out. Not like it went to like midnight and it cut off in the middle of the test. But it's cool. Take mine out.
I made it 2 chances so that if you have problem with that, the first try, you can then do the second attempt. We'll see. If I'm going to open it, I will let you guys know. Okay. If I'm going to open it, I will send a message that is open or not. Okay. All right. Let's see. The next thing I want to show you is this. Tomorrow we start a new topic, which is probability distribution. This one here. So the note is here. Lecture 5 here. So you can download it. And there's one more thing I want you to download. It is the statistical table. We'll start using this table on this one here. We'll start using it from Wednesday. You're all there, right? Hello?
Yes, we're here. When
Yeah.
I'm here.
Yeah.
So let me take your attendance. And then we can leave. Today is 19. Okay, it's right here. I can see excuse me. Let me see who can I see here? I see Hammock Machine.
Yes, I'm here.
You can leave. Dolly, I see you. You can leave now.
Bye.
Tiffany Walker, you can
Here.
leave. Vanessa Vanessa is not here. Have Bista. I have you Bista, so you can leave now. Measure, who's Measure?
Yeah.
Before I leave, I have a question.
Hold on there.
So-
You can ask me.
So yesterday I was trying to go into to do the test 1 after I finished the homework 3. Once I finished the homework 3, I was not able to click test 1 at all. And I emailed you about it, and so one of the other students had the same concern. I'm pretty sure she emailed you too.
If
And
you
there was-
if you click it after the due date, the time is due at 11:59. If you click
No,
it
it
after
was
that time,
it was definitely before that.
hold on, let me finish attendance, then I can have a better answer for you. Okay. Debbie. Rita Ford, I see Rita Ford.
Professor, did you get my email?
I haven't checked.
Yeah, I
checked.
emailed you too. I didn't get any response.
Sorry about the last week. It was busy week, so I haven't checked very much my email this week. So I'm gonna check it and see what is going on. But the test is
Yeah, I emailed you too.
See, like everybody emails you, and a lot of people had the same concern.
so don't go. You know what? Let me get this this thing out first. Bucket, Debbie. Hello. Okay, I got it. Bucket, guys, bucket. Yes. Okay. All right. Now you are talking about the test 1, right?
In the homework one, I couldn't access homework one either.
Test 1.
Well, homework 3, sorry.
Test 1 is right here. Homework 2 is past due, so you cannot access it anymore at this point. So test 1 is right here.
Mm-hmm.
If you try it after it is.
No, it was way
It
before.
was way before.
Yeah,
I
it was
couldn't get homework 3 or test 1. Like I kept clicking on it in outs and nothing popped up.
One. 18. Okay, now. If I can make it. Now, click on it again.
Okay, let me try. If I could show you from my computer, I would. Like, it's still not working for me.
Is what again?
No, it's not. Like, if I could show you,
Go ahead.
let me share my screen. It says you disabled it. Can I share my screen, Professor?
Go ahead.
You have to stop sharing first.
Yeah.
And can you enable sharing, please?
Can I do what?
It says host disable participant screen sharing. So you have to go there and enable it.
Okay, you can share it now.
Okay. Start. Okay, here it goes. Where was it here? So this is a test, right? Look, I'm clicking on it and it's not working. I'm clicking on this, it's not working. Okay.
Let me go back there.
Mine did that the last time, but I think there's something you need to do first before you click on it. So
I mean, I've done everything else. I've done homework 1, homework 2, homework 3.
the data.
So, Ms. Doll, is your own working now?
No, I did mine. It did not let me access my data. The data you know, the one I shared last week.
Yes.
So it kept saying I should do the test first. So I had to do the test, even though I was not prepared for it. I had to do the test first before it let me do the assignment.
I already did the assignment. I was able to do the homework 3 because it came before the test, and then the test came up. I was trying to do that, and when I try to click on it, it's not clicking.
Yeah, mine did not let me do the homework.
Can you try it with another browser? Maybe Firefox.
Firefox. Well, like when I go to Canvas and click on Alex, that's where it takes me. So
yeah, that's what I'm saying. Go to close that browser. Go to Firefox or Microsoft Explorer. Then go to from Explorer. Go to Canvas, because it might be from your browser.
hold on.
Hold it, something is wrong somewhere. I think so. Not from her. I don't know from her. From I don't know, but that thing gave me problem the entire time.
What's that?
I mean the Alex. I think it's from Alex because I had to do everything it wanted me to do before I could access my my assignment for 3.
Let's not try this then. You see. Because sometimes it might be a browser.
Yeah, she need to call Alex too because I called Alex. I put their number and called them.
If you try this one, if it doesn't work, because now I opened it again. I can make it up to Friday. So let me make it up to Friday. So call Alex. That's the one as far as I could go. So it's open again. Try Alex. Try in a different browser. That's what you call clearing the caches. Clear all the caches and try it again, because everything is set there. And the fact that some people have done it already means that it can be done. So many of you have done it. At least half of the class have done it. So then you can call, if that one doesn't work, call Alex. Their tech support, and then they can tell you what to do. Yeah.
Okay, so that one is due the 23rd.
Yeah, I moved the due date to 23rd.
Okay. All right, I'll try to call Alex and figure it out. Okay, thank you.
Do you want the number so I can give it to you?
What's that?
The number, the Alex, the number. If she wants, I can give it to her.
Sure,
That,
that would,
when you order the code, it's on their number is there.
Oh, okay.
Their number or email where you can get them.
yeah, I'll figure it out. Thank you, darling.
Okay. All right. I see you guys tomorrow.
Professor,
Yes, ma'am.
I had emailed you to let you know my brother had passed, and so it's been, really hectic. On me because I'm the one have to get everything in order and together, and mentally I'm not even here. My body here, but that's it.
Hold on. Give me a number again. Let me call you.
443 979 5021.
Let's go to what?
5021.
5021.
Huh?
5021.
Yes.
443 979 or 977.
979.
Right, I'm gonna call you.
Okay.
All right, I'll see you guys tomorrow.
And it don't want to let me.
No question before I leave. One of your students, Taijay, she's having an issue like Dolly did, where she's not able to click on it. So she should call Alex too.
Have issues with what?
Should she call Alex too and figure out?
What kind of problem is Miss? Is it Taijay? You are there, right?
Yes.
So yeah, I think you speak for yourself. Don't let. Are you hiring Miss Beast as your lawyer?
No, I was just we were having a conversation about it because we were having the same.
How much is she paying you, Miss Beast?
I'm not paying her anything. Go ahead, Taiji.
I just want to make sure that's all.
So I can't open it at all. So when I try to do it, it just won't do anything.
You click on it and it doesn't pop up the exam.
Yep, it doesn't.
So,
That or the homework.
try it in a different browser. Like you can go to Internet Explorer, like my words, like this one here, or Firefox.
I just think it's weird because I could open up everything else and then it just stopped me all of a sudden.
That means you're gonna be Alex, call them or email them. Their contact is in the
Can you show us where it is, the Alex contact, if you're able?
The code you bought the code or the book is there at the back of it. So the right support. Yeah.
Okay.
All right. Again, I think I have said this like 4 times. I'll see you again tomorrow.
All right. See you.